Welcome to the monthly webinar we are organizing with Telerex. Today we have the honor to have Mr. Kent Yen from the company Cincon in our midst. Vandaag hebben we Kent Yen van de firma Cincon in ons midden. Aujourd'hui nous avons Monsieur Kent Yen qui va nous expliquer les choses qui sont importantes pour les AGV et les AMR. Puisque tout le monde comprend l'anglais et on a pas mal de clients qui sont anglophones, je vais continuer en anglais. So, let me take you through the general structure of our webinar one more time. It's a webinar which takes approximately 45 minutes. Half an hour is dedicated to our presenter and the interesting technical content. And afterwards, we have more or less 15 minutes free to answer some questions. You can put your questions during the presentation in the chat. I will follow this offline, and at the end of Mr. Kent Yen's presentation, I will take the questions one by one and put them to him. In the case we have many more questions which we cannot cover in 15 minutes, we will take the pleasure to organize the answers for you directly, and we will do that next week. As always, this webinar is recorded, so in case you and or your colleagues would like to revisit the webinar, it's always possible. We will send you the link to the recording after this webinar. Now, let me introduce to you our presenter of today. It's Mr. Kent Yen. He's the product manager for Power Industrial at the company Cincon. Cincon is a global supplier of switch mode power conversion products for many different industries. They have been doing this already since 1991. They are producing and R&Ding from China and from Taiwan. They have both AC-DC as DC-DC converters. The subject that Mr. Kent Yen will cover today is actually to explore the power solutions, especially for AGVs, AMRs, and drones, and explain to you real-world application. He will explain the innovations that Cincon is doing and the advantages that those bring to its customers. Mr. Kent Yen, the floor is yours.
Hello, everyone. This is Kent Yen from Cincon Electronics. And quick introduction to myself. So I'm right now in Cincon's product manager, so kind of understand all the product and application to our customer and support our customer. So today I'm going to give you guys the presentation. So today's topic is the automation application in the AGV, AMR, and drone power solutions. So before we started the presentation, let me give you the general Cincon Electronics. Our mission is we focus on high efficiency, compact, and reliable power solutions. Our real focus is the power supply itself and provide a really good solution to our end customer. So for today's agenda, let me quickly give you an introduction here. So we will focus on the AGV AMR. First, what's the AGV automatic guided vehicle and AMR autonomous mobile robot and the drone? These three different, we call it robotic automated solution equipment. Then I'll briefly talk about their structural block diagram, because to know those applications, we need to know their structure that provide a solution for them. Then I'll share some project case sharing that Cincon have been done with some AGV AMR case and the drone cases, how we provide solution for our end customer and what's their need. Then I'll also share some successful stories Cincon have been done with the customer and why they choose Cincon's product. And by the end, of course, I will give you some our hot sale product for those applications that are suitable for these applications. So the AGV means that automatic guiding vehicle on here, the left-hand picture here, and AMR means autonomous mobile robot, which is automatic walking robot. So what's their difference is in the original manufacturing line, they use lots of AGV mostly. And the main difference is the AGV need to follow the line. As you see on the floor, there's a line guidance the AGV to where to go and where to pick up the cargo and where to drop it. So and any obstacle in front of AGV, it will start the AGV. It cannot be as smart like right now can route it like the AMR. So AMR is like kind of advanced devices that promoted from AGV. So right now it can go by itself by the sensors around it, and it can go around the obstacle instead of stop it. And in the design flexibility, AGV is more restricted, but for the AMR actually is more easy to write a map inside its MCU and able to route it by itself. And of course, from the cost perspective, AGV is most cost effective, but AMR is more expensive. And in the application right now, we see lots of those vehicles in the manufacturing line, especially those warehouse. You see lots of them also using a lot logistic and medical, like hospital right now start to use some MR robotic to use it. And agriculture and mining, they are kind of using it. So this is really popular right now. We see the AGV MR using in the market right now. So here's some application we see in lots of places. One is the warehouse that we see, like Amazon warehouse, we see lots of them used it. And another is a package delivery. Right now in some cities, I think in Europe, not only in Europe, I think in Taiwan or China, they also use some package delivery AMR or AGV to deliver some package itself. And restaurant use the AMR to deliver the foods. And agriculture right now, we see some mowing robotic. They use the AMR to organize their grazes mow on their field. And of course, in the manufacturing line, they integrate the robotic on the AGV MR to use to assembling some products. So these are the really popular application we see for the AGV MR applications. So here is what's their structural block diagram internal. So from the beginning, like AGV MR, they are driving by the battery. So in the front, there's a charging circuitry. The AC, you can see the AC from a wall plug, then charging the battery. And the battery support the AGV MR's whole electronic devices. So battery can support maybe 24 volt, 48 volt, then going through the DC-DC converter or other convert the voltage to the component they needed. Usually internal, there's a main MCU series, MCU control part that control like sensors or motors, driver, or memory and everything. This really depends on how complicated your AGV MR is, and it will require more electronic component and require a higher voltage in it. So in here, in the right-hand side, you see the picture. This is more in a simple way to describe AGV MR structure. So the main power is a battery here. So there's might be a DC-DC converter to drive the actuator that I can give you some to lift up the cargo or lift up the devices. And in some MCU or control board, they might require special like 5 volt or 3.3 volt power. So it can convert from the 24 volt battery to the 5 volt or 3.3 volt and to the end equipment needed voltage. So as you see that the power converter actually play the role between the battery and the end devices. So that's the main DC converter play the role here, right here. Yep. So here's some case sharing, Cincon been done. So this is for AMR, automotive delivery robotic. They use the 24 volt battery. So customer actually choose most of our Cincon's product with a 24 volt to convert to no matter still 24 volt or 5 volt on their sensor, screen, or camera here. This is a reference picture, but right now lots of AGV MR, they more equipment, more complicated devices like sensor around it or monitor around it, and even some camera to sensing the the surrounding environment. And another is the motor drive, the 4 wheels. They will require the drive to power for this AMR. So the customer use the 24 volt to 12 volt to drive the 4-wheel motors to drive this AMR vehicles. So this is the two example that the customer needs 24 volt to like 5 volt or 12 volt needed on the AMR applications. And another case sharing, this is as you see the picture in the middle here, is used in the warehouse. It will need to lift up the cargo or lift up the devices or equipment. So that will have two powerful actuator. So that's why you see a customer choose one of the 4-brick, the 600 watt in each, to lift up this motor on this actuator, I think. Yeah. And another is the application that customer use a 48 volt battery. They might have a 4 of a 12 volt battery to in series to 48 volt. So they will require to drive 4-wheel on it. So they also do the one of a 1 kW to drive 2 motors, and another 2-wheel with 1 kW to drive 2 motors. So this is another example like high power needed in those we call it lifted AMR applications on those. So yeah. Also some successful story on the AGV AMR warehouse automation. Cincon's by the end I'll give you the summary of the Cincon products here. But here is the ones our CNFC, which is a chassis mount product. They use it in the AGV AMR 150 watt. So one benefit is it can adapt to wide input ranges and convert to the 12 volt. And the customer choose this because school terminal is much easy to directly install in the AGV-AMR instead of design them on PCA board to support the power on it. So I think that's the most of the reason why customer prefer to use the we call it all-in-one solution here, to just plug in the wire and directly to use it. Yeah. So on the previous slide was talk about the AGV-AMR application mostly, and use the DC-DC converter. And next, we'll talk about a drone and UAV, which is a manned aerial vehicle. And those vehicles right now is really popular in the application right now, no matter in the consumer, commercial, or even in some defense applications. So these 3 pictures you see here is the currently we see most on the market right now is a consumer smaller one. Usually it doesn't really have a really weight, so the battery doesn't need to have a high voltage. It's usually under 18 volt, and power is less than 200 watt, and payload is only 250 gram, which is not really high heavy one to be used. Then another is in the middle ranges is the commercial one, which is a battery will be up to a little bit up, but still less than 60 volt, and power will be less than 6 kW, and payload can be several kilometer, and weight is 25 kilogram. So this is, it might be used for some cargo shipping or delivery mission on it. Yeah. And the other one is the main drone. So main drone is more like a smaller helicopter. So usually internal battery voltage will be higher because higher wattage power will needed, over 1,000 kW. And payload may be used to to carry the man on it. So it could be go up to 140 kilogram on it, and the weight will be larger. So you can see the pictures here show the smaller consumer and commercial and man carry drones on here. So speaking of those drones, their application we see that right now in the defense and military application, such as some defense mission will be surveillance or strike some special target to strike on it, and transfer the goods like medical goods or some supporting goods for the front end soldiers. Yep. And another civilian drone, which is not using in the defense but more in the civilian applications, like photography, like taking pictures. As we see lots of drone right now can take high altitude picture to surveillance the surroundings. And logistic is also right now one popular trend that you can carry the deliveries to places. It can really deliver some, especially like high mountains. Sometimes it's hard for men to reach, and right now the drone can really deliver the package to those areas. And another is right now the firefighting and agriculture. They can spread some, no matter water or extinction or some agricultural needed spread to certain area. So that can be able to, do some task that in the past really hard for men to do it all at once. But you can see another tool is the surveying and inspection. So these are the two also popular right now. The drone can really go into a high altitude and surveying the surrounding and the surrounding environment or building or do some measurement. That's right now most popular in the drone application. So also let's check their block diagram. So this is provided by Infineon block diagram here. So in here also the main power is by a battery. So no matter AGV AMR or drone, those robotic devices, actually they are all powered by battery. So battery can be like 20-volt or higher voltage, as you see that, and it will definitely need a DC-DC converter inside, because inside it also have some sensor, camera, and even some lifting product or MCU that will require the different needed over voltage. That's why the DC converter played an important role here. So this is a more clear picture of one example. You see the batteries right here, then going to a DC-DC converter, then have the controller here. And controller, they might control the sensor, camera, so DC converter play a role, the needs of voltage of the camera or sensor, and even some wireless communication and GPS. And of course, these four motors play an important role to lift up the whole drone. It's more like it's similar to the AGVMR. They will need a wheel motors to drive it going back and forth. And drone, the motor played an important to lift up the whole drone and systems. So the next, we can check the power source of this drone. This is what we summary right now on the popular application of the drone. So one popular is the battery power drone. Usually it will use like 12 volt, 24 volt, or 48 volt battery on the drone itself. Battery power drone on this. And also we see another type of drone is a solar power drone. So solar power drone is, you see that its power actually is not only from a battery, but it will taking the solar power to convert to the energy to charging the battery. And usually we'll see the power input voltage will go up to 100 volts on it. And another is right now a tether drone. So tether drone usually play an important role that under surveillance. Although it was restricted by the wire length to surveil the surrounding area. But one good benefit is the drone will able to stably. It will not be loose or not able to recover it. So right now tether drone is also Cincon have lots of good project to a tether drone, and it will require around 300 to 400 volt on the tether voltage. So one case sharing here is earlier we are approaching by a customer to doing tether drone, and they will require the 300 VDC input, a DC-DC converter. And Cincon have one series of DC converter have a 200 to 425 VDC input to convert to 12 volt for like camera or some MCU devices inside. So this is a good solution for customer in the beginning. But also by the end, the customer was asking that if Cincon could provide more like total solution for them. So in Cincon's new AC/DC power supply solutions, Elephant series, most of them can be adapted to the DC input. So in these cases, customer needs 750 watt, instead, they choose the AC/DC LFN 750, which is able to adapt the 300 volt as well. So this total solution for customer, by the end they think this is their preferred to use it, because all the surrounding circuitry like EMI solution has been already included. They don't need to design their own PCBA board and to embed this DC module on it. They use the AC/DC power supply to use on their drone. Yep. Also another is also a tester drone. So the needs also the 300 VDC input to 12 volt as well. And the wattage needed is about to 1.4 kilowatt needed. And operating altitude is 5K meter, because the drone needs to go up really high. So the customer was care about if you're a DC-DC converter, you can be working on a high altitude. And Cincon's DC-DC converter, we actually passed one of the mile standard A10F, this standard. This is the high altitude standard that can able to ensure our product can work in a high altitude. And this is not only for drone application. Some of the they will require the power supply or your DC converter need to meet, ensure they can working in a high altitude without failing or some accident in it. So that's why the reason actually customer was really happy with our Cincon's product, able to do this verification on this. So the following is speaking of those application and a successful story and case. Cincon have lots of DC converter able to meet the requirement, and this is our summary table, and able to tell you that from the low wattage to high wattage and the different input voltage. In the left-hand sidebar here, you can see that this is from 24 volt input, 48, 110 to 300 VDC input. Cincon can have a solution on those input voltage to convert to like 3.3, 5 volt, 12 volt, 15 volt, and to 48 volt. Usually, for a drone or AGV AMR, they are preferred to use like 3.3 or 5 volt for their MCU controller. And sometimes for their motor driving, they might want to use a 12 volt or 24 volt. So I would say this 3.3, 5, 12, 24 might be most popular. They will choose for AGV AMR and drone applications in our experience. And also you can see the different package also will be considered by the customer if their size needed and wattage needed. Yep. And also Cincon have a wide input ranges DC-DC converter. And with this, there's a good benefit is some design, a customer only need a 24 volt because they use the 24 volt battery as the input. But some of the design, the customer use a 48 volt. So different voltage input, they might require different DC-DC converter. And with the ultra wide input DC converter, their one benefit is no matter which VE voltage, actually right now they can use one converter to use in the design scenario. So those are the wide input ranges. For example, like 9 to 75 volt, it covers 24, 48 volt input here. And even with higher ranges, like 40 to 160. So right now, if your customer need 24, 48, even they going higher to 110, they can be covered by this DC-DC converter. So this really saves the design engineering's effort that they can use one source to design in the different power board they needed for different model. They don't need to select different model on it. That's the benefit of the wide input ranges DC-DC converter. So this is the plug-in and play solution with our DC-DC converter integrated. So in the earlier page of the one successful story, I mentioned one AGVMR. We actually customer select our one of 150 watt CNFD. I think this one. So this is good benefit is the way it did it is we put a DC-DC converter in the bottom and put a PCBA board including EMI filter and screw terminal here. So customer they needed is just use the wire to direct it into input and output and get a power in output. So in some cases, a customer can save their design time and use this to chassis mount on their system and directly get the power. So we also have lots of selection from 20 watt to 750 watt with a CNFD, CNFC, or ECRT solution, which is all the total solution and chassis mount. And I think this is the end of the slide here. So this is our AC/DC power supply elephant series. This is our new series. So those power supply have AC/DC power supply have one feature. Because the AGV/AMR or drone application, normally they only need the DC input. Because they are driven by battery, of course they need the DC input. They don't need AC in. But this AC/DC input power supply, they can adapt to the DC input as well. So which is the 120 to 370 VDC input. So this feature actually suitable for some drone application, especially tether drone. They will need it because they use a tether to transport the power. They will require like 300 to 400 VDC input. So if a nominal is 300 VDC input, they could use this elephant series to use in a drone application. And one good benefit is this elephant series, the size only 1 inch is low profile, which is really thin, low profile, thin size. So to put it in their drone, it's not as big as the traditional power supply. So and the total weight will be not that high. So that's why some customer instead of choosing the DC converter with high VDC input, they sometimes would thinking and consider to choose our elephant series to put in on their drone applications. Yep. So I think this is the end of my presentation today. So feel free to ask me any questions or any want to discuss on the application experience I have. Yep. Thank you.
Okay, Kent, thank you very much. That was a very quick overview and a nice overview of your products which you have available. What I liked about it is that you're very, very specific in saying in this application we use this one because of that, and in that one application we use the other one because of this reason. That's something I like. Now, in the meantime, there are a number of questions that have popped up, so let me just read them to you and we will take them one by one. The first one goes like this. Are Cincon DC-DC converters certified for demanding environments like transportation or defense-grade robotics?
Yep. So in the DC converter itself, it was categorized as a component. So as a component, usually the end customer, when they do your safety, they usually put our component inside and do the safety integrated together. But in the DC converter itself, we actually have the standard like a UL and the CE. That's a standard we have. And some customers, they will require like defense application. For example, like the high altitude testing. Sometimes they will require like 461, which is used lots in the defense and drone application. We could do that for the customer. And even we internal Cincon have the one what we call the EMI chamber able to test the like 461 standard on it. So that's why in the Cincon's DC converter we able to do some specific certification for the customer they needed. Yep.
Okay. Okay, I have another question here, which is a little bit related. Is can Cincon DC-DC converters handle harsh environmental conditions? I presume that the question is related to agriculture and well, difficult environments. Huh?
Yep. So in the Cincon's DC-DC converter, you can see they are all encapsulated. So encapsulated, which means it passed the for example, like the A10, that's the most mild standard A10 shock and vibration. We have a verification and pass on it. And also in Cincon, we have a whole testing equipment, which is testing the limitation of the power supply itself. What's the vibration, the maximum it will fail, and what's the maximum temperature, go up to 150 degrees C, can fail, for example. So those DC converters, they are really good for harsh environment, and Cincon did verify them with our internal capability to test on them.
A new question popped up. Are the converters R10 certified for automotive solutions?
Currently, no. R10, I think, is for more in automotive solutions. And currently, Cincon's DC converter mostly we follow with the railway EN 50155 certification on that. Yeah, that's the most of Cincon's right now product following on.
To round off is to say, remember that we are doing this every single month, and every single month we have a very interesting speaker like Kent, and we intend for 2026 to do exactly the same thing. So, gentlemen and ladies, thank you very much for your attendance, and wishing you a nice working day. Goodbye.